Hello and welcome to Mr. Powers Teaches Algebra. We are in section 1.6. We are now looking at rational expressions. First, we're going to reduce. Then, we are going to multiply and divide, which is just like reducing. So that's easy. Then we're going to add and subtract. That's it's a lot more work. Still doable. So that's what we want to be able to do with these guys, these looking guys. So what are rational expressions? Nothing more than a fraction in which the numerator and denominator are polynomials. Give me this. Polynomials. There we go. Here are some examples of rational expressions. 6 over x minus 1, z squared minus 1 over z squared plus 5, and so on. And now this one's interesting. 4x squared plus 6x minus 10 over 1. You know what? Isn't that the same as 4x squared plus 6x minus 10? I mean, do we really need the over 1? You know that's what that is. But it's good to make a note and emphasize that 1 is a polynomial. Therefore, polynomials by themselves can be counted as a rational expression, as can 6 over 1. You can do it. 1 is a polynomial of degree 0. Work. Oh, my mute button does still work. Should remember that. Okay. So those are rational expressions. Moving on. Now, how do we reduce rational expressions? Well, the same way we've always reduced them. Because we've done rational expressions, back when we just called them fractions, back when the numerator and denominator were only integers. Like this guy, 12 over 8. How do you reduce it? Well, you divide top and bottom by the same thing. Now, we don't want to think about it like that anymore. We want to factor it first and cancel out common factors. Because this really is just another way of saying 4 over 4 times 3 over 2. Because when you multiply fractions straight across, 4 over 4 is 1. So it's like 1 times 3 over 2. Those cancel. That's why we can cancel these and end up with 3 over 2. So using that same thinking, that same philosophy, we can do rational expressions. That is, when the numerator and denominator are polynomials. Here we have a factored rational expression. The numerator's factored and the denominator's factored, and they both have an x plus 3 as a factor. So we can cancel those out. And it's important when you hear me say cancel out common factors that they are factors. Factors are expressions that are being multiplied by other expressions. This is all multiplication up here. X plus 3 times x minus 1. So the x plus 3 can get canceled out because it's being multiplied by something on the top and the bottom. We can cancel those out, okay? That is how we reduce these guys. So it's really straightforward. So let's go ahead and do an example. Here we have one that is not factored. So we need to factor it so we can see if this is reduced or not. So I'm going to go ahead and factor the top. Let me see here. I'm thinking 2 times 4 is 8. 1 times 8 is, it's a terrible one. Oh, no, 2 times 4. Okay, yeah. X minus 2. Let me see. X minus 4. Let's see. That's not going to get me negative 8. I need negative 8. So let's make this plus. There we go. So x plus 2 over x minus 4. Bigger. There we go. There, okay. And that's the factorization of the top, the numerator. Yep. Denominator, what do we get? Let's see, 4 times 5 is 20, 4 plus 5 is 9. My little tricks that I know. So let's go x minus 4 times x minus 5. And we get our factors for the denominator. Okay, cancel out anything in common. X plus 2, nope. No x plus 2 is on the bottom, but x minus 4, yes. We got those. So our reduced expression is x plus 2 over x minus 5. And I don't need the parentheses. I don't know why I wrote those. Let's see. X plus 2 over x minus 5. Piece of cake was that one. It's too easy. All right. Let's try another one. Let's try one here. We got time. It's only been 5 minutes, almost 6 minutes. Pff, it's too easy, this stuff. Let's just get this stuff done. Hey, who said you could change? All right. X squared minus 25 over 5x minus x squared. Factor, factor, factor. Let's factor these so we can see if there are common factors or not. Top is a difference of squares, obviously. So let's factor that. I get x minus 5 times x plus 5. That guy's factored. The bottom, I don't see a difference of squares like on the top, but I do see a common factor. In the first term and the second term here, I see an x. So I can write x times 5 minus x. Ooh, a little tricky here. Okay, good. I like it. So you'll see here that x minus 5 and 5 minus x. Oof, they're so close. They're so close. So there's a trick. And here's the trick. Test this out. But a minus b is the same as negative b minus a. Go ahead, multiply this negative through, treat it like a negative 1, and you will see that negative 1 times b is negative b, negative 1 times negative a is positive a. Change the order, that's a minus b. So this is a little identity we have to use sometimes. So this is a great example. Because this 5 minus x and x minus 5, they're almost the same, but really, it's not a 1. It's a negative 1. If you divide these, you get a negative 1, not a 1. Because it's almost the same, right? So, what do we do here? What do we do? Let's take out the negative. I like to keep the negative in the numerator. So, yeah. We'll take out the negative from the top, and I can rewrite this as negative 5 minus x times x plus 5. So I just change that x minus 5 to negative 5 minus x, all over x times 5 minus x. Now I can do some simplifying. Now we can go bam. I don't want, come on, give me another color. Bam, bam, gone. And now I get negative x plus 5 over x. And I would leave it like that. If you really wanted to do something, you could distribute the negative in, but it really doesn't make a difference unless you're using some homework system on a website or in a program that wants it a particular way, or you got multiple choice and it could be this one. They don't show it, they show this one, that kind of a thing. But that's how we would do it. All right. So, or, eventually you get so good at it, you just realize, oh, I can cancel these, but I got to throw a negative 1 somewhere. So, throw it at the top. Okay. Last but not least, we have this guy. We can do it. Why not? We're on a roll. Not that you need this example. If you want to quit, fine, go ahead. But let's do this. Man, first thing I see is a common factor here. X to the 7, x to the 6, x to the 5th. There's definitely at least an x to the 5th in each term. So I'm going to factor that out, because that's what I do. So x to the 5th times x squared gets me x to the 7th. Let's see here. To get 2x to the 6th, I multiply by 2x. And x to the 5th times 1 is x to the 5th. Okay. So I got the top factored. Ooh, but does this factor more? It might factor more. Let's look at the bottom here. The bottom is factored. X cubed, and then I got an x plus 1 to the 8th. So here we got two factors, x 3 times and x plus 1 8 times. Okay? Let me see. Well, it's one. I mean, maybe I should say x with the multiplicity of 3. But anyway, let's go ahead. Can we factor this? We definitely can. I recognize the numerator here, x squared plus 2x plus 1 can be written as x plus 1 times x plus 1. And you'd expect something like that. Like they set it up. You know, there's x plus 1 to the 8th. What's the chances we're going to have an x plus 1 up here? We have two of them. We got two of them up there. All right. So anyways, keep going here. So we got x cubed times, and you know what? I'm going to say x plus 1 to the 6th times x plus 1 squared. Because I want to break this up. I just feel like it's going to help me. Because x plus 1 to the 6th times x plus 1 squared is x plus 1 to the 8th. Now I can I can see that I can cancel this with these two. There are two x plus 1s on the top, 2 on the bottom. Got rid of them. And now I can write this guy out. Completely reduced. X to the 5th over x cubed times x plus 1 to the 6th. And I am done. I'm not going to multiply all that out. Man, what a nightmare that would be. Unless you know the binomial theorem, which you should. Should you? Anyway, that is it. That'll do it for this video. So hopefully you find that useful. All we did was do a little reducing rational expressions, and it's really easy if we've got that factoring down. So until next time, enjoy doing math.